And let's start, I guess. So we'll continue with SQL. Please let me know if you can hear me or if you have any questions at any point. So last time we talked about the set operations. Let me share screen. Okay. So set operations, we said you have union all, which combine the results of two select statements. You have union, which combines also the results of two select statements, but eliminating duplicates, which is not done in the union all. You have intersect, which is set intersection, and set difference using except. We'll do an example. So union between father child and mother child. Basically, we want to get a table that, right, a temporary table which contains everything that is in father child or mother child. And we can do this using the union operation. So let me try it out in MySQL. Okay, so here is it. Can you see MySQL? Yes? Anybody? Okay, good.
Yes, we can see.
Okay, great. So now I run this query. So I execute select father child from father child, union select mother child from mother child. And this is what I get. Right, so I get, sorry, here it is. I get basically everything that is both those tables together, right? So the table with two columns. The default is that you use the names of the columns of the first table, right? So the names of the columns of the first table. So here we get father child first, so then I get father and child. And inside the records, I get, right, all the fathers and their children, and then all the mothers and their children. So that's union between these two tables. Okay, good. This is the same query. So basically select father as parent and child from father child union, select mother as parent, comma child from mother child. All I see, the difference is that I see the table name, the column's name in the temporary table, the result table would be parent and child rather than father and child. If I run the query, I say go. I see now parent and child rather than father and child. So just a nice, addition, small addition, yeah, to make the results read better. Okie dokie. Now, we're going to talk about something else today, which is nested queries. This is a very powerful technique in SQL. So it allows you to write really powerful queries. It's used a lot. It's a bit complicated, so hopefully we'll go through it slowly today and it should be clear. Yeah. So what is nested queries? The where clause of one select statement. So I can have a select statement, and its where clause can contain a condition that refers to the result of another select statement. So you basically have a subquery in the where clause, which is another select statement. In particular, you can have comparisons of one attribute or several attributes, the result of the subquery, so the subquery coming in the where clause, or you can have existential quantification, which you should remember from 211, CMPS 211. Yeah, so there exists. We'll see examples of all of this in a bit. For example, let's say we want to find the name and income of Frank's father. Let's do this first without a nested query. How do I find the name and income of Frank's father? So I say select, I want name and income from the table person. And then I need to join this table with father child, right? Because the information about the father is in the table father child, if you remember. Yeah, so I need to select name and income from person, comma father child. where, right, I want the name to be that of the father because I want the name and the income of the father, right? And whose father do I need? I need Frank's father. So the child is equal to Frank. So select name and income from person, comma father child, join these two tables such that name is equal to father, so that the income you get is the income of the father, and then make sure that the child is equal to Frank. Okay? And then I do go, and this is what I see. I see Steve and 23. Yeah, so Steve is the name of the father, and his income is 23. If we look at the schema, okay, the father of Frank is Steve, okay, and Steve makes 23K per year. Okie dokie. Is there lagging this time? No? Okay. Good. Now, let's do this using nested querying. So let's see the query. The query says select name and income from person. Yeah. When name is equal to, and then I have another sub-query, right? Select father from father child where child is equal to Frank. So what happens here? Yeah. You take the outer query, and for every row in the table of the outer query, so basically for every person, I go and check whether, right, it satisfies the condition, the where condition. Yeah, so basically I'll go say first row was Steve and Frank. I'll go and select, right, Steve, his income, and then check is name equal to, select father from father child or child is equal to Frank. So I execute this query, right? So this query gives me who's the father of Frank, it's Steve. So basically it will be as if I'm saying select name and income from person where name is equal to Steve. Yeah, and that should select me the correct record in the table person. Yeah, so really it's just, if we run it, just to verify, I want to select name and income from the table person. If I do this alone, I'll get the name and income of everybody, but I want the name and income of, right, Frank's dad. So where name is equal to, how do I select the dad of Frank? It's from the table father child. So select father from father child where child is equal to Frank. So the inner query gets me, this inner query gets me the father of Frank, that's Steve, and then the outer query gets me name and income from person where name is equal to Steve, the father of Frank. Okay, let's execute it. And I see that I get again the same answer, Steve and 23. All right. Yes, I'm using full screen in the PowerPoint. Okay. So in general, right, I can do equal. So basically I can have in the where clause an attribute equal and then another select statement, but this select statement must return one value only. Yeah, so when I use equal, can use greater than, less than, but then the sub-query or the inner query must return a single value. Okay, so okay, so and basically I can, in the where clause of the outer query, the result of an inner query can be used in equality and other comparisons. So greater than, less than, the result of the inner query must be one constant value. Otherwise it will not work. I can't say equal to multiple values at the same time. Yeah. So what happens if the result of the inner query is a table? So it returns multiple records. then I can use some of these keywords or operations, right, to answer the whole query, the nested query. Yeah, so we have any, all, in, and exists, and you can negate these two also, in and exists. We'll see examples of all of this. Okay, let's say I want to find the income of fathers of people who earn more than 30K. We've done this query before. So find the name and income of fathers of people who earn more than 30K. Let's do it first without a nested query, and then we do it with a nested query. Okay, so I want to find the name and income of people who earn. Okay, so name and income from person, that's in the table person, right? And I have two persons here, person F, and I'm gonna join it with father child, FC, and then person C. Why do I need two joins? One to get the income of the child and one to get the income of the father. Okay, so which income do I need and name? It's the father. So f.name, f.income. Okay, what is the where condition? I have join conditions. So f.name is equal to fc.father. Okay, and f and c.name is equal to fc.child. So one copy for the father, one copy for the child. That's the joining. And I want the c.income to be greater than 30 because I want fathers of people that earn more than 30. Okay, so select f.name, f.income from person, father, child, and person, where I have the join conditions, right? So and, okay. Now let's run it. And I get the following, Greg and 40. So Greg makes 40K and he's the only father of, right, a child that earned more than 30. Let's verify this. Here's the table. Here's the schema. So I have Steve, right, is dad of Frank and of only Frank. How much does Frank make? 20. So Steve will not be included, right? Because Steve is not a father of somebody who makes more than 30. Now let's look at Greg. He's the dad of Kim and Phil. Kim makes 41, so it's greater than 30. So I should return Greg, right? Let's see Frank. Frank is the dad of Andy and Rob. Andy makes 21, Rob makes 15. Both of them do not qualify, so I should not include Frank in the final result. And this is why I get only Greg when I execute this query. Okay, okay. Good. So let's do this using a nested query. Okay. So we're going to use the any operator. Yeah, the any operator is true if the comparison is true for at least one of the result tuples of the inner query. What do I mean by this? I mean that, right, this inner query would return multiple rows, multiple records. Now, if the condition is true for any of these records, then I would return the record. So I take every record in the outer query and check if, right, the where condition is true for any one of the results of the inner query. If that's the case, I return this record. Yeah, so let's see this in action. Let's say I want to select name and income from the table person. What do I need? I need, right, where father equal to, right, sorry, where name, there is no father here, where name equal to any. And then select from father child, comma person, where child is equal to name. So basically, I want to join this such that, right, it's for the child and income is greater than 30. So what does the inner query do? It selects all the fathers, right, the names of the fathers of those people who earn more than 30. Now, the outer query get me the name and income of any person where name is equal to any of these fathers. So this query would return all the people, all the fathers, right? A list of all the fathers that whose children earn more than 30. And now this one would return anybody, right? The name and income of anybody that is in this list. The list of fathers whose children make more than 30. Okay, let's execute this query. And you get again Greg and 40, right? That's the only dad that makes whose children make more than 30. Okay. Why do you put any? Because what does the result? What does the query return? This query returns what? Select fc.father from father child, comma person, where fc.child is equal to c.name and c.income is greater than 30. It returns a list of values. Yeah. So a list of values. I want, right? Now, these are the fathers. These are basically the fathers of all the people that make more than 30K. Now, it's a list. So I want to find the name and income of every person in this list. Yeah. So let's say this list was Steve and Greg, two values. Yeah. So I want to find now the name and income of both Steve and Greg. So equal to any of these results, the results of the inner query. That's what it means, any. Does that answer your question? Okay, good. The n operator. So it's similar to equal any. So if I say equal any, it's exactly the same as saying n. Yeah, this operator n. So to find the name and income of the fathers of people who earn more than 30K, I can do it in another way. Nested query using the n operator. Let's do it from scratch. So here I'm gonna do any join. So I do two nested queries, yeah, or two subqueries inside one large nested query. So select name and income from person. That will give me the name and income of everybody. But I want only those who are fathers. So select father from father child, where child n. And then I'm going to do another nested query. Select name from person, where income is greater than 30. Okay. So let's see this query with two nested subqueries. The inner query, this one, the highlighted one. What does it do? It gets me all the people whose income is greater than 30. Great? Okay. So I get a list of all the people whose income is greater than 30. Now the second one, this one, get me fathers of, right, anybody who's a child of anyone that earns more than 30. So I got a list of names that earn more than 30. Now check who is the father of anybody in this list. So that gives me a list of fathers whose children earn more than 30. So these two queries, right, give me basically a list of names of fathers whose children earn more than 30. Now finally get the name and income, right, of these fathers. So select name and income from person or name in this list of fathers. Yeah, so I used nested querying to get, right, the information by breaking it down into, right, two subqueries. And as expected, I get Greg and 40. Yes, so you can substitute joining by nested querying. Yeah, so this is doable. However, we're gonna talk about this in a bit. We're gonna talk about the trade-off between nested querying and joining. So usually joining is more efficient. It's easier to think in terms of nested querying, but joining is more efficient because nested querying, what happens is the subquery is executed once for every record in the outer query. Okay, good. The all operator. So what is this operator? So we looked at equal any, which is the same as n. Yeah, so it's very intuitive what it means. The all operator one second. Okay, the all operator. True if the comparison is true for all the result tuples of the inner query. So if I have an inner query, okay, I will, and then I use all in a condition, then it's gonna return a record in the outer query only if it's true for all the results tuples of the inner query. So again, this inner query, right, the subquery would return a list of results. If all of these results satisfy the condition, then I return the record from the outer query. Otherwise, I skip this record and move to the next record. For example, let's say I want to find the people who have income higher than the income of all people younger than 30. Okay. So I have, right, to find the people, the income of people who are younger than 30, and then find, right, people who earn more than these guys. So how do I get the people who earn more than 30? That's a select income from person where age is less than 30. Yes. Okay, so that's, if I run this query alone, this is a flat query, it will just give me the income of people who are less than 30. So I get 21, 30, and 50. Yeah, basically, these are the ones that earn less. These are the incomes of people whose age are less than 30. Yeah. Okay. Now I want to use this list of incomes to select people who earn more than this, more than all of this. So select name and income from person where income is greater than all. Select the income from person where age is less than 30. What does this mean? It means that I'm gonna only select the name and income from person, so records in person, that satisfy this condition. The condition is that the income is greater than all the values that are returned by the inner query. So all the incomes of people whose age is less than 30. We looked at the people whose age less than 30, that's their income, 21, 30, and 50. So basically I want all the people that earn more than 30. Yeah, that's really the semantics of the query. Let's see it. We run it. What do we get? We get the following. Anne, right? Her income is 35, so it's greater than 30, yes. Greg, 40, so greater than 30. Kim, 41. Lisa, 87. Mary, 42. And Mike, 35. So all of these are the people that earn more than anybody whose age is less than 30. Yeah, so it's very powerful. I use the nested querying to be able to do something very sophisticated here. What happens if I change this to any? I don't understand your question, Muhammad. What do you mean can we write when age is greater than 30? So I need to do two things. I need to find out what is the income of people who are less than 30. So I want to find this. How do I do this? This is one select statement, right? Get me income of people who are less than 30. I can do this without a query. Yeah, I don't know it. It could be anything. It could be any value. So that's the goal of the first subquery. If I do select name and income from person where age is greater than 30, that would give me the name and income of people who are greater than 30. This is not what the query wants. The query doesn't want the name and income of people who earn more, who are older than 30. If we run the query that you're suggesting, let's try it. Select name, income from person where age is greater than 30. That gives me the name and income of every person who's older than 30. Yeah, that's different. Let's run it. All right, it got me these people, right? For instance, Frank, right, makes 20. This did not appear in the result of the other query, right? And we got other people that do not appear here. What is the difference between this query and the query you're suggesting? This one just gets me the name and income of people whose age is greater than 30. This one, the one we had before, gets me the name and income of people whose income is greater than everybody, right, who's less than 30. Can we use the aggregate maximum to get the maximum salary of the people who are younger than 30? Yes, exactly. So we can do that as well. So let's try it out with maximum. So I can say select name and income from person where income is greater than, select maximum income from person where age is less than 30. So this one would get me the maximum income of all the people who are less than 30 years old, okay? And then I get the name and income of people whose income is greater than this maximum income. Okay, if I run it, I get again, right, all the people who make more than 30 because the maximum was 30, right? The maximum of people of income of people who are less than 30 years old was 30. If we look at the result of the subquery, yeah. So I get the same results as the previous one. So yes, I can do this, right? Income greater than all, or I can do as one of you suggested and say, okay, select, right, here asterisk, so I'm getting the name, age, and salary of the person whose income is greater than the maximum income of people whose age less than 30. Hopefully this is clear now. Okay, so we need to, in 10 minutes, we'll have to restart the meeting again. So all you have to do is just log in again, tune in again, use the same link again, you'll be able to join the meeting. Yeah, so I'll start the meeting with the same link and you will be able to join it again once the time expires. Okay. Questions? Good. The exists operation, right? This one is a bit difficult. So it's similar to existential quantification in logic. So to turn true, the result of the inner query is not empty. What does this mean? Let's see this query. Yeah, so select star from person where exists. Select father from father child where father is equal to name. What does this mean? It means that I take every row in the outer query. So I have select asterisk from person. That will give me every person in the table. And then check whether, right, the inner query returns something for this record. So I'm selecting father from father child, where father is equal to the name of the current record. Yeah. So if that returns some result, then where exists becomes true, and I return this record. If that doesn't result any result, then I get this to be empty, and I get where exists is false, and I don't return the record. So what is this query doing? It's basically getting me the name and income of every person who is a parent, so has at least one child. Yeah. So select asterisk from person, where exists select father from father child, where father is equal to name, or exists select mother from mother child, where mother is equal to name. Let's run the query first, and then we'll see alternative ways of writing it. So I wanna find everything from person, such that we don't get everybody, we get only the people who are parents, so our fathers or mothers. Where exists, what exists, select asterisk or name, it doesn't matter, or father, child, where name equal to father. So this would do what? This would get me the basically information about the fathers. Yeah, only fathers. So if I run it, I get Frank, Greg, and Steve. Out of the table person, I get only Frank, Greg, and Steve. If you look at the schema, our database, yeah, these are the fathers, Steve, Greg, and Frank. Yeah, I'm selecting only information from person that happen to be, Steve, Greg, or Frank. Right. So this will get me the fathers. How do I get the mothers? So, or exists, yeah, select mother from mother child, her name is equal to. So now get me basically also the mothers, yeah. So if I run it, I should see now the mothers. So Anne, Lisa, and Mary, Frank, Greg, and Steve. These are the parents in the database. Yeah. The other ones, Rob, for instance, is not included because Rob is not a father. Okay. Also, Kim is not included because Kim is not a mom. Let's understand just here what's happening here. I'm referring to the name, attribute from the outer query. I'm allowed to do that. In a subquery, typically where I'm using exists, I can refer to a column from the outer table in the inner query. Yes, there is and exists, like or exists. There is not exists as well. We'll see variations of this. So you can do and, or you can do anything. In the where condition in general, you can do any logical operation. So you can do anding, oring, not, and so on. Okay, good. Just one more thing about this query. So how does it get executed? Yeah, you need to understand this. So it's select star from person. So what happens is I go to every record in person. So the first record in person was Andy 27 and 21. Okay, so the name is Andy, and then I apply this query. Select father from father child where name is equal to Andy. And see, does this query return, this inner query return any results? If it returns any results, then this becomes true, where exists becomes true, and this record is returned as the result of the whole query. Since Andy is not a father, this inner query, select father from father child when name is equal to Andy, would not return any results, so it will be an empty result set. And so what exists is false, and this row, Andy, 27 and 21 would not be selected. Okay, same thing happens for every record in person. This is how the subquery is executed. It's executed once for every record in the outer query. Okay. Can I write it in another way, this query? So using, for instance, the N operator. So I want to find the people, everything about the people, are fathers or mothers. So select the asterisk from person, where name N, select father from father child. So that would get me right information about all the fathers. Or name N, select mother. So the subqueries, what do they do? This gets me a list of all the fathers. This gets me the list of all the mothers. And then I'm selecting star from person where name in this list or in this list. If I run this query, should get the same results as the one we did with where exists. Yeah, and Frank and Greg and Steve and Mary and Lisa. These are the moms and fathers in the database. The other people are not included. Questions so far? Okay. Okie dokie. Okay, here's another way of doing the same query using the union operation. So I'm gonna not use a nested query, I'm gonna use instead joining and union operation. So I'm gonna say select asterisk father child, comma, person, where name. One second, I'll answer your question in a second. When name is equal to father. So that I joined father child with person, such that right person is father, union select asterisk from mother child, comma, person, where mother. So now I'm joining and I'm doing union. And if I run the query, I get, again, right, the same result, but right, there are repetitions here. So Steve, right, Greg and Frank, because it's union,